All right, today we're going to kind of continue with our sort of review of things that we've done in the past, whether it be fourth grade or fifth grade with fractions, but things that are very important to us to be able to move forward to our ultimate goal of being able to multiply and divide fractions. And so today I'm going to sort of do a two-part lesson. It's what we worked on Thursday and then Friday. The first part here is going to be about writing equivalent fractions. The second part then will be about simplifying fractions and reducing fractions. So let's take a look at writing equivalent fractions. I've got a few vocabulary terms that I want to discuss with you guys before we move on, and these hopefully are going to be review things that you've heard before. The first vocabulary term I have is a fraction. The fraction just is pretty simple. It's just a way to show the part of a whole. It's a ratio that shows the parts of a whole. We usually write them a number on top of another number. So for example, 1/2 or 3/5. When it comes to writing fractions in math, I really strongly discourage you from writing the fractions like this. And the reason being that as we try to do some of the things that we're going to do both today and in the future in the next couple weeks, writing the fractions with this sort of slant line, it really doesn't work for you. It makes it difficult to line things up. It makes it difficult to do the addition, subtraction, multiplication, division. So make sure that you are writing the fractions like what we see here. Next vocabulary term we have is numerator, and that's the number that's on the top of the fraction. So in those fractions I wrote at the beginning, it would be the numbers 1 and 3. Make sure you use the word numerator. We like to use proper math vocabulary in class, so I hope that you guys will start using the word numerator instead of the number on top. That follows up with the denominator, which would be the number on the bottom of the fraction. And then lastly, equivalent fractions. And when you hear the word equivalent, you probably hear equal, and that's essentially what it means. It's two fractions that represent the same part of a whole. It's two fractions that are equal. They mean the same thing. So let's go ahead and take a look at this stuff. And right here I've got a little bit of a model. Get this out of the way. And I want to know what it would look like if we shaded in this box to represent 1/4. You can see I've got a box here that is broken up into 4 pieces. So if I'm going to make a model that looks like 1/4, I'm going to shade in 1 out of the 4 pieces. Now, you'll have to forgive me. I'm not going to spend the time to shade this in perfect. But notice 1/4 is represented here now by having 1 out of the 4 pieces shaded in. But what would happen if we decided to cut the box into 8 pieces instead of 4 pieces? Is that going to change the shaded part? Do I have to change the shaded part in order to do that? Well, let's take a look. I'm going to go ahead and make lines here. And if I cut this part in half here, and this part in half here, I have 8 equal sized pieces, or as close to equal as I can get there. So take a look at that. Did I have to change the red part, the part that was shaded in? And you'll notice that the red part was not changed one bit. I didn't have to increase it or add more or erase any. The only thing I did was I just cut that into more pieces. So now if we look at this, now we would say that this box is cut into 8 pieces and 2 of the 8 are shaded in. So a fraction that would represent this model now would be 2 shaded pieces out of 8 total pieces of the whole. So that brings me to this question then. How do we get from 1/4 to 2/8? We have to be able to do things mathematically. Yes, I can draw a model to show it, but as you guys start working with the models, you'll notice that it's harder to draw models that match up evenly and have perfect lines and perfect sized spaces. I needed to show how I got from 1/4 to 2/8 mathematically. Now, if you look at these sets of numbers, I hope that you're able to see a connection. The connection is this. I can do something to both the 1 and the 4 to get to 2 and 8. So take a look at that. Think to yourself, what could I do to the 1 and the 4 to get to 2 and 8? And if you said multiply times 2, you're absolutely correct. If I take 1 times 2, that is 2, and 4 times 2 is 8. And that's exactly how you write an equivalent fraction. You have to multiply both the numerator and the denominator by the exact same parts. Remember when we talked about dividing decimals by other decimals, and we moved the decimal place on the outside of the division, and we treated them like brothers and sisters. And I'm going to have the same analogy for this as well. We're going to treat the top and the bottom numbers, the numerator and the denominator, just like brothers and sisters. Your parents, if they're going to be nice and do something or give something to one of you, they got to do it to the brother and sister. So we're going to do the exact same thing to the top as we do to the bottom. And that's an equivalent fraction. 2/8 is equal to 1/4. It's pretty simple. Let's try to write an equivalent fraction then for 2/5. The neat thing about writing an equivalent fraction is it really doesn't matter what number we use. For example, I'm going to do the exact same process this time, but I'm going to multiply times 4. Okay? So if I take 2 times 4, that gives me 8, and 5 times 4 gives me 20. 8/20 is the exact same as 2/5. So what that's saying is that if I have a pizza, and I take it out of the oven and I cut it into 5 pieces, and then I eat 2 pieces, that's the exact same amount of pizza if I took the pizza out and cut it into 20 pieces and I ate 8 pieces. So while the pieces are smaller, in order for us to eat the same amount, we have to eat more. So when the number on the bottom gets bigger, the number on the top gets bigger. The numerator gets bigger, the denominator gets bigger. Because as we cut it into more pieces, we have to eat more pieces to equal what we had originally. And you can use any number at this point. So for example, if I wanted to do another one, another equivalent fraction would be, let's multiply this time by 7. 5 times 7 is 35. 2 times 7 is 14. 14/35 means the exact same amount as 8/20 and 2/5. Now, besides the rule that you have to do the same to the top as you do to the bottom, you have to do the same to the numerator as you do to the denominator, the other rule that I have is that there's one number that we do not want to use. And in this case, that number is 0. Now, why is that? Why would I not want to multiply times 0? If I take 2 times 0, I get 0. If I take 5 times 0, I get 0. 0 over 0 means that I have nothing and I've cut it into no pieces. Is that the same as saying I have a pizza cut into 5 pieces and I have 2 of them on my plate, or I've eaten 2 of them? That doesn't work. So when you multiply times 0, it does not give you an equivalent fraction. So do not use 0 to multiply by as an equivalent fraction. Some of you might be saying, well, what about if we used 1? Well, that works to some extent, but if you do that, does it give you anything different than you already had? 2 times 1 is 2, 5 times 1 is 5. You haven't written a fraction that is equivalent. You've written the exact same fraction, so it doesn't really help you in this sense. Okay? This is going to come into play when we start working on finding a common denominator for our fractions. Let's try 3/7, and then I'm going to have you guys try some. 3/7. Let's go with, I'm going to go 10, a little bit bigger of a number this time. I'm going to multiply the numerator and the denominator by the exact same numbers. 3 times 10 is 30. 7 times 10 is 70. And right there I have an equivalent fraction. You can choose any number. There's an unlimited amount of equivalent fractions you can write for every fraction that I would give you. If I give you the fraction 3/7, you could start right now writing equivalent fractions, and in 3 hours still not even come close to writing all the equivalent fractions there are possible. You can just choose any number to multiply and keep going. You try one. Now I want you to pause the video and try to write an equivalent fraction for 2/3. What number should you use? Doesn't matter. Just try it. Let's see if I can guess what you used. I'm going to do a few and see how you did. I'm going to start off with the easiest and most common one, and that's multiply by 2. 2 times 2 is 4. 3 times 2 is 6. I could do it times 3. 3 times 3 is 9. 2 times 3 is 6. I could do it times 4. 2 times 4 is 8. 3 times 4 is 12. You can do it times 5. 2 times 5 is 10. 3 times 5 is 15. I could do it times 6. 2 times 6 is 12. 3 times 6 is 18. And I could go on and on forever. Hopefully, one of the ones that you chose is up here. If not, as long as you did your multiplication correctly, it's correct. If you multiplied both your numerator and denominator by the same number, and you did the multiplication correctly, you got an equivalent fraction for 2/3. It's pretty simple. Now, I'm going to go to the second part of our presentation for today, and that would be over simplifying fractions. And let me get my screen up that I want here. All right. Well, we started off the last one. We had one region shaded in, 1 out of 4, and we turned it into 2/8. Well, now I want to see what happens if I go backwards. So right now I have 2 boxes shaded in out of a total of 8. So it gives me 2/8. Well, what happens if we reduce the number of pieces? So what happens then if I get rid of these 2 pieces I put in at the beginning of the last example? Now how many pieces are shaded in? 1. Out of how many total pieces? 4. Again, the idea here is to understand, how do we get from 2/8 to 1/4? How do we mathematically do that? Now, hopefully you're looking at that and thinking to yourself, how did I get from 2 to 1? How do I get from 8 to 4? If you're really, really clever, you're going to start thinking about, well, wait a minute, last lesson, or the last activity we did, we were going from 1/4 to 2/8. I know that we multiplied. What would be the opposite of multiplication? The opposite of multiplication is division. So what if we tried this? 2 divided by 2 and 8 divided by 2. Remember, we have to treat them like brother, sister. What we do for one, we have to do to the other. 2 divided by 2, is that 1? Absolutely. 8 divided by 2, is that 4? Absolutely. So we have a fraction that has been simplified. Those both mean the exact same thing, but instead of going from a smaller number or a smaller fraction to a larger fraction with larger numbers, we're going from larger numbers to smaller numbers. This is what we call simplifying or reducing the fraction. Hopefully you heard about that in probably 4th, maybe 5th grade. Okay, so let's simplify 4/8. The one thing we talked about in the last section was that there's an unlimited amount of equivalent fractions you can write because you can multiply by anything. But when we do this one, can you divide by any number? Can you divide 4 by any number you want to and get a whole number? No, it doesn't work. So we're going to have to use our divisibility rules on this one. So let's think about our divisibility rules at 4 and 8. And I know right off the top of my head I have 2 even numbers. And that tells me that if I have even numbers, I can always divide by 2. So let's try that first. 4 divided by 2 is 2. 8 divided by 2 is 4. 2/4. Awesome. One thing you always have to ask yourself as you simplify fractions, and this is the key question: is there anything I can divide the numerator and the denominator by and get a whole number? So I look at 2 and 4 in this case. Is there anything else I can divide 2 and 4 by and have it come out evenly? Hopefully you said yes. There's one more thing we can divide by. 2 and 4 are both even numbers. We can divide by 2 again. 2 divided by 2 is 1. 4 divided by 2 is 2. Now there's a couple things here. A couple ways to know that we're in simplest form. Number 1, I can promise you whenever you have a 1 as your numerator, you're in simplest form, because 1 is only divisible by 1. And we're not going to keep dividing by 1 in this case, because it would be 1/2 again, and then 1/2, and then 1/2, and you'd continue doing 1/2 over and over and over again. Another way is to think about prime numbers. Anytime you have 2 prime numbers, I can guarantee that you've got a fraction in simplest form. We do have a fraction in simplest form because now the only factors of 1 is 1, and the only factors of 2 are 1 and 2. So now we're at a point where we can't simplify anymore. 1/2 now is said to be in its simplest form, or in the simplest fraction. Okay. Now, some of you might say, well, I don't want to make it do 2 steps. I was looking at this and I noticed that I could divide by something other than 2. For example, 4 can be divided by 4, and 8 can be divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. And in one step, you did exactly what we did in this spot up here. So, there's something that you can see that we've done that's very, very similar in both cases. Notice up here we have divide by 2, divide by 2. Down here we just have divide by 4. If we take and divide by 2 twice, if we take those, put those together, 2 times 2 is 4. How do we know what number we can use to only make it be one step? If I don't ever want to have to do multiple steps, meaning I have to do like I did up here, where I do divide by 2, then divided by 2, and there's some that might take you up to 3 or 4 steps. How can I figure that out? Well, one of the things you can do is you can look at the greatest common factor. Let's list the factors of 4 and 8. I can multiply 1 and 4 and 2. 1 times 4 is 4, 2 times 2 is 4. Factors of 8 are 1 and 8, 2 and 4. And notice the greatest common factor is 4. If you find the greatest common factor of the two numbers, you can divide by that number and it will only take you one step to get it in simplest form. Okay? So it's a matter of how do you want to do it. Now, some people might argue, well, it's just as easy to divide by 2 twice as it is to find the greatest common factor and then do the division. Whichever way works for you. But finding the greatest common factor can make it much quicker. Let's try another one. These are some bigger numbers here. 20/40. Okay. Now, again, I can find the greatest common factor. But at this time, I'm just going to sort of work myself through it. I'm looking at this and I'm going to say, you know what? I noticed something about these two numbers and the divisibility rules that we have and what I want to do. These both end in zeros. And I know from my divisibility rules that I can always divide by 10 if numbers end in 0. So 20 divided by 10 is 2, and 40 divided by 10 is 4. Again, I have to ask myself, can I divide the numerator and the denominator by any other numbers and have it come out as whole numbers? In this case, yes, I can. They're both even numbers. Let's divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And I have the fraction now in the simplest form. You could approach this a lot of different ways. Another way that you could approach this is to start off by dividing by 5. Any number that ends in a 0 is also divisible by 5. 20 divided by 5 is 4. 40 divided by 5 is 8. This looks familiar like the one we did right here. We know we have to divide by either 2 twice or 4. Let's divide by 4 since we already know. 4 divided by 4 is 1. 8 divided by 4 is 2. Couple different ways to get to the answer. Do I care whether you start off by dividing by 10 or divide by 5? Doesn't matter to me. I don't care if you figure out that their greatest common factor is 20, and you could start by dividing by 20. However you get to the answer is the best, is what works for me. As long as the end is what we need, you're good to go. Notice again, 10 times 2 is 20. 5 times 4 is 20. If I do my factors of 20 and 40, 1 and 20, 2 and 10, 4 and 5, 1 and 40, 2 and 20. Sorry, it's getting a little small here. 4 and 10, 5 and 8. They share the greatest common factor of 20. So again, my 10 times 2, my 5 times 4 still equals 20. If I take 20 divided by 20, that gives me 1. And 40 divided by 20 gives me 2. However you need to do it works for me. You try one. Try simplifying 50 divided by 100. Go ahead and hit pause. Start however you want and get it in its simplest form. All right, let's see how you did it. One of the common mistakes I see when we have something like this is that we say, ooh, I know what I can do. I can divide by 10. They both end in 0, which is great. We can do that. 50 divided by 10 is 5. 100 divided by 10 is 10. And a lot of times I see students stop here. But we've got to make sure we continue until we have no more numbers that I can divide both the numerator and the denominator by. In this case, I can still divide by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Not sure how you did it. You might have started off by dividing by 2. You might have started off by dividing by 5. You could have divided by 25. Lots of different ways you could have started this. But my hope is that when you got done, this was the answer you had left. Okay? Not every answer is going to be 1/2. It just so happens that the fractions I chose today ended up that way. Okay? Remember, when you're making an equivalent fraction, you can multiply by any number you want to. But when you're simplifying, you have to choose a number to divide by that both the numerator and the denominator are divisible by. Use your divisibility rules. Think about the way that what those numbers look like, and if you can divide them by 2, by 3, by 4, by 5, by 6, by 9, or by 10. Use what you know about the greatest common factor, whether it's making a list or making a factor tree, to find the greatest common factor, and you can do it in just one step instead of like I had to do here where I used 2 different steps. It's your choice. Figure out what works best for you. As long as you get the end result that that everybody else does, that's what we're looking for. All right, well, hopefully you guys learned something, and come see me if you need any help.